Look around you at all the colors you take for granted. The purple of a phone case, a child's crayon, a cheap plastic toy. Purple is everywhere and it costs nothing. Now travel back 2,000 years, and that same color would have been the single most expensive substance on Earth, worth more than its weight in gold, and forbidden, on pain of death, to almost everyone alive. This is the story of how that happened. How the most precious color in human history became the most ordinary, and how it was cracked open, by accident, by an 18-year-old boy on his Easter holiday chasing something else entirely. It's a story about a failure that changed the world, and about how our whole modern age of medicine and chemistry began in a pot of black sludge. But to understand the size of what he did, we have to understand purple. Because for most of history, purple wasn't just a color. It was power itself, made visible. It meant royalty, godhood, untouchable wealth. And the reason comes down to a small, ugly sea snail and an almost unbelievable amount of labor. The color was called Tyrian purple, named for the ancient Phoenician city of Tyre, whose people first mastered it. It was extracted, drop by precious drop, from the glands of murex sea snails. And it took a staggering number of them. To make just over a single gram of pure dye, you needed something like 12,000 snails. 12,000 animals crushed for a smear of color. That's why it was so absurdly expensive. Purple dye was, quite literally, worth more than gold by weight. The Roman Emperor Diocletian, in the year 301, set a price ceiling on it. A single pound of purple-dyed wool was to cost the equivalent of about 3 pounds of solid gold. Imagine a fabric so dear that it outvalued gold 3 to 1. So purple became the color of the untouchable elite. Roman emperors wore it. Byzantine rulers signed their decrees in purple ink and wrapped themselves in purple silk. There were even laws, sumptuary laws, making it a serious crime for an ordinary person to wear the royal color. To be seen in purple without permission could cost you your life. The prestige ran so deep it soaked into our language. A child born to a reigning emperor was said to be born to the purple, born into the highest possible rank. We still use that phrase today, and most people have no idea it comes from a snail dye, so rare that only the very summit of society could afford to be stained by it. And here's the crucial thing to hold in your mind. This wasn't a color that was sometimes expensive. For roughly 3,000 years, through the Phoenicians, the Greeks, the Romans, the Byzantines, purple stayed at the very top. Century after century, no one found a cheaper way. The snail was the only source, and the snail was scarce. Purple's throne seemed permanent. By the 1800s, that specific snail dye had actually faded from use. The ancient techniques were largely lost, the Byzantine dye works gone. But the idea of purple as the ultimate luxury color lingered. A rich, deep, permanent purple was still one of the hardest colors to make and to keep. Dyes faded, ran, washed out. A true, lasting purple remained a kind of holy grail for dyers. Because that was the deeper problem with all color. For all of history, every dye came from nature, and nature is stingy. Red came from crushed insects and madder roots. Blue from the indigo plant, grown and harvested across whole continents. Yellow from flowers and bark. Each color meant farms or forests or oceans. Vast labor to wring a little pigment from the living world. So color, in the year 1850, was still fundamentally agricultural. Bright, rich, fade-proof colors were a luxury. The clothes of the poor were the colors of dirt and undyed wool, browns, grays, dull naturals. Vivid color on your body was a signal of money. And the brightest, rarest, most aristocratic color of them all was still, in memory and meaning, purple. Now hold that world in your head. A world where color is scarce and purple is king. Because it's about to be shattered. And it's going to be shattered not by a dyer, not by an artist, not by anyone hunting for color at all. It's going to be shattered by a teenager trying to cure a disease in a makeshift lab over a school holiday. To meet him, we have to talk about a completely different problem, one of the great scourges of the age, malaria. A disease that killed millions and, crucially, tormented the sprawling British Empire. British soldiers, sailors, and administrators posted to India, Africa, and the tropics were falling sick and dying of it in enormous numbers. Malaria wasn't just a health crisis. It was a threat to an empire. There was exactly one thing that worked against it, quinine, a bitter compound extracted from the bark of the cinchona tree, which grew in South America. Quinine could treat and prevent malaria. But it had to be stripped from tree bark, shipped across the world, and there was never enough of it. It was expensive, and supply was always tight. The empire was desperate for more. So chemists had a dream. What if you didn't need the tree at all? What if you could build quinine from scratch, in a laboratory, cheaply, and in unlimited quantity? Synthesize the cure. Free the empire from its dependence on distant bark. It was one of the great chemical prizes of the day, and one man in London had made it his mission. His name was August Wilhelm von Hofmann, a brilliant German chemist who had been brought to London to run the new Royal College of Chemistry. Hofmann was fascinated by a strange, dark, smelly substance that was piling up as industrial waste all over Britain, coal tar, the gooey black residue left over from making coal gas for lamps. ugly, useless-seeming stuff that Hofmann suspected was chemical treasure. Coal tar, Hofmann knew, was a rich soup of carbon-based compounds. One of them was a substance called aniline, a colorless, oily liquid. And Hofmann had noticed, roughly, that aniline's chemistry had a certain family resemblance to quinine. It was a hunch, a hope, maybe, just maybe, you could rearrange the cheap coal tar aniline into precious quinine, turn waste into medicine, turn tar into gold. Now, we know today that this hunch was chemically naive. Quinine is a complicated molecule, and the crude methods of the 1850s had no real hope of building it that way. But nobody knew that yet. It seemed a reasonable, exciting goal, and Hofmann had a young assistant, a teenage prodigy, restless and eager, who decided to take a crack at it himself, quietly, on his own time. That assistant was William Henry Perkin. Born in London in 1838, the son of a builder, he had fallen in love with chemistry as a schoolboy, so much so that he'd enrolled at the Royal College of Chemistry at 15, and by 17 was Hofmann's personal research assistant, brilliant, obsessive, and barely more than a child. In the spring of 1856, he was 18 years old. And that spring, the college closed for the Easter holidays. Most students would rest. Perkin went home, to a rough little laboratory he'd built for himself on the top floor of his family's house, and decided to spend his break attacking the great problem himself. He would try to make quinine from coal tar. What happened next was one of the luckiest failures in the history of science. Let's step into that attic. It's Easter, 1856. William Perkin is 18, working alone in a makeshift home lab, with a plan to synthesize quinine. His approach was to take an aniline-like compound derived from coal tar and treat it with a strong oxidizing agent, potassium dichromate, hoping the atoms would rearrange themselves into the precious anti-malarial molecule. It was a shot in the dark, and he knew it. Here is the quinine molecule he was chasing, an elegant, intricate structure of carbon, hydrogen, nitrogen, and oxygen. Recreating something this complex by simply oxidizing a coal tar chemical and hoping was hopeless by modern standards. But Perkin didn't have modern standards. He had a hunch, a holiday, and a lot of nerve. He mixed his reagents and waited to see what would form. And it failed. Of course it failed. Instead of forming clean, pale crystals of quinine, the reaction produced a dirty, reddish-brown sludge. A mess. Chemically worthless-looking gunk clinging to the bottom of his flask. Any sensible chemist would have simply scraped it out, cleaned the glass, and tried again with different conditions. That is exactly what most people would have done. But Perkin apparently tried a slightly different starting material, a simpler compound, aniline itself, and this time the reaction gave him a black precipitate, black sludge. Even less promising. 2 failures then, a holiday's work producing nothing but muck. And this is the moment where the whole story turns, not on a success, but on Perkin's decision not to throw the failure away too quickly. Because Perkin was curious about his black sludge. Before discarding it, he went to clean the flask out, and the standard way to dissolve organic gunk like this was with alcohol, with spirits, so he poured alcohol into the flask to wash away the worthless black mess. And as the alcohol hit the sludge and dissolved it, the liquid turned the most extraordinary, brilliant, intense purple he had ever seen. Stop and imagine being 18 and seeing that. You've spent your holiday failing to make a medicine. You're literally in the act of cleaning up your mistake. And suddenly, your rinse water is glowing with the richest purple you've ever laid eyes on. The color of emperors, blooming out of a pot of industrial waste. Most people see a mess to be washed down the drain. Perkin saw something else. Perkin saw a color. This is the part that makes Perkin more than just lucky. Luck put the purple in his flask. But it was his mind that recognized what it might mean. He knew, because it was the color of royalty, the color worth more than gold, that a rich purple was hugely valuable. And he wondered the crucial question, could this strange purple stuff actually dye things? Could it color cloth? Would it hold? So he tested it. He took pieces of silk and dipped them into his purple solution. And the silk drank up the color, turning a gorgeous, even, vivid purple. Then came the real test, the ones that mattered. He washed the dyed silk. The color stayed. He left it in sunlight, which faded most dyes to ghosts within days. The purple held. It didn't wash out. It didn't fade. It was fast and brilliant and permanent. Do you understand what that meant? For 3,000 years, a permanent, brilliant purple had required a fortune in crushed sea snails. And here was an 18-year-old with a purple made from coal tar, from industrial waste that factories were paying to get rid of, that clung to silk and shrugged off both water and light. He hadn't made a medicine. He'd made something arguably more valuable, a cheap, fast, beautiful royal purple. Perkin named his new color mauve, after the French name for the mallow flower, and he called the dye itself Mauveine. And almost immediately, he did something that shows how sharp this teenager really was. He grasped that this wasn't just a pretty result for a scientific paper. This could be a business, a world-changing product. He decided then and there to try to turn his accident into an industry. But there was a problem, and his name was Hofmann. Perkin, still a teenage assistant, went to his eminent professor with his discovery. And Hofmann, the great chemist, the serious academic, was distinctly unimpressed by the idea of his brilliant young protege abandoning real science to go and make dye. To Hofmann, this looked like a gifted student throwing away a research career to become a tradesman. He tried to discourage the whole thing. You can almost sympathize with Hofmann. In his world, chemistry was a noble intellectual pursuit, and commerce was beneath it. Dyeing was a grubby trade. A talented young man's place was in the laboratory, publishing discoveries, building an academic reputation, not dirtying his hands in a factory chasing money. It was, from Hofmann's point of view, sound and caring advice. It was also completely historically wrong, because Perkin ignored him. This 18-year-old, against the explicit advice of one of the most respected chemists in Europe, decided to bet everything on his purple accident. He filed for a patent on his new dye. And remember how young he was. Patent law in Britain at the time didn't even normally allow someone under 21 to hold one. Perkin was so young, he was pushing the very limits of who was legally allowed to own an invention. The patent was granted on the 26th of August, 1856. William Perkin, 18 years old, was now the legal owner of the world's first commercially viable synthetic dye. Not a color taken from a plant or an animal or a rock, a color built by human beings from the discarded waste of the coal gas industry. Nothing like it had ever existed. He had, without quite realizing the full scale of it, opened a door. But a patent and a beaker of purple are not an industry. Between Perkin and his fortune lay an enormous chasm. He had made Mauveine once, in tiny amounts, in an attic. To sell it to the world, he would have to make it by the ton. He'd need to manufacture aniline in bulk, which nobody did. He'd need factories, processes, machinery that didn't exist. He was 18, and he had to invent an entire industry from nothing. And for that, he would need money and faith. He got both from the one place that would believe in a teenager's coal tar purple, his own family. His father, a builder, had spent a lifetime saving. His brother was ready to join him. Together, the Perkins were about to gamble everything the family had on a color that had, just weeks before, been a mistake at the bottom of a flask. Perkin's father, George, made the decision that would define the family. He took his life's savings, the money a builder accumulates over decades of hard work, and put it into his teenage son's purple dream. Perkin's older brother Thomas joined too. They formed a company, Perkin & Sons, and began building a dye factory at a place called Greenford Green on the outskirts of London in 1857. Everything the family had was now riding on mauve. Now the real genius showed itself, and it wasn't the accident, it was the grind. Making Mauveine in an attic and making it in a factory were utterly different problems. Perkin had to figure out how to produce aniline cheaply and in bulk, starting from benzene in the coal tar. He had to invent the equipment. He had to work out how to get the dye to bond to cotton, not just silk. He solved problem after problem, mostly himself, still barely out of his teens. And here, let's pause on the color itself. Because why was it purple? Every dye works by swallowing some colors of light and reflecting the rest. Mauveine's molecules have a hungry appetite for green light, right in the middle of the spectrum, around a wavelength of 550 nanometers. It absorbs the green and lets the blue and the red bounce back to your eye. Blue plus red together is exactly what your brain reads as purple. It's a small miracle of chemistry that a molecule cooked up by accident from coal tar should absorb light in exactly the band that produces the world's most coveted color. But that's what Perkin had stumbled into, and once his factory ironed out the process, mauve began to flow, not in drops now, but in quantity. For the first time in history, brilliant purple could be made by the barrel, cheaply, on demand. The 3,000-year monopoly of the snail was over. But making the dye was only half the battle. Perkin now had to convince the world to buy it, and the British textile industry was conservative, skeptical of the strange chemical color from an unknown teenager. He had to travel to dyers, teach them how to use Mauveine, prove it wouldn't ruin their cloth. He was salesman, chemist, and engineer all at once. Slowly, the orders started to come. And then something happened that no marketing could have bought. Fashion happened. Across the channel, the French Empress Eugénie, wife of Napoleon III and one of the great style icons of the age, took a liking to the new mauve. It's said the color flattered her eyes. When the most fashionable woman in Europe wore mauve, every fashionable woman in Europe suddenly had to have it. And the demand didn't just grow. It detonated. Then came the ultimate endorsement. In 1862, at the Great International Exhibition in London, Queen Victoria herself appeared in a magnificent gown dyed with Perkin's Mauveine. The Queen of England, the sovereign of the empire, wearing a color invented 4 years earlier by an accident in a teenager's attic. The most royal purple in the world was now, literally, made from coal tar. It was a coronation for the color, and for Perkin, what followed was a full-blown craze. Mauve exploded across Britain and France. It was on dresses, ribbons, bonnets, gloves. Everywhere you looked, the streets were turning purple. The satirical magazine Punch had a field day and coined a perfect mocking name for the mania sweeping the country. They called it the mauve measles, an outbreak of purple spreading through the population like a rash, an epidemic of fashion. Think about how strange and wonderful this was. A color that had, for 3,000 years, been walled off for emperors and kings, reserved by law for the highest of the high, was suddenly on the back of any shop girl who could afford a few yards of printed cotton. Perkin hadn't just made purple cheaper, he had democratized it. He had taken the color of absolute power and handed it to ordinary people. The social walls that color once built were crumbling, and the money followed the color. The Perkin family's gamble paid off spectacularly. Orders poured in from across Britain and the continent. The Greenford factory expanded. That builder's life savings, bet on a teenager's purple, had grown into a genuine fortune. William Perkin, still in his early 20s, was becoming a wealthy man, and, quietly, one of the most important industrialists of the century, though few yet understood why. But here's the part that reaches far beyond one lucky color. Perkin had proved something enormous, an idea that would remake the world. He had shown that you could take cheap, abundant coal tar, the black industrial garbage of the age, and build from it valuable, complex, brand new substances that did not exist in nature. He had demonstrated, for the first time, the power of synthetic chemistry, and other chemists were watching very, very closely. The message was electric, there was gold in coal tar. If a teenager could pull a fortune in purple out of it, what other colors were hiding in that black soup? Chemists across Europe, especially in Germany where chemical science was booming, threw themselves at coal tar with feverish energy. The race was on to discover new synthetic dyes, and they came, in a flood, color after color after color. Within just a few years, the drab natural world of dyeing was overrun by dazzling synthetic hues. Brilliant magenta, named after a bloody battle of the era. Vivid aniline blues and greens, new violets, some made by Hofmann himself, who had come around rather quickly to the value of the field he'd once sniffed at. A whole rainbow that had never existed before was suddenly pouring out of coal tar, cheap and bright and permanent. And this transformed everyday life in a way that's easy to overlook. The world literally got more colorful. For all of history, bright color had been a luxury of the rich. Now, ordinary people could wear vivid greens and blues and purples, homes, clothes, printed pictures. The visual texture of daily life brightened for everyone. Cheap synthetic color was one of the first mass luxuries of the industrial age, a small democratization of beauty itself. Perkin himself kept pushing. He didn't rest on mauve. He tackled one of the biggest prizes in dyeing, alizarin, the brilliant red pigment that came from the madder plant, grown across thousands of acres of farmland. In 1869, Perkin worked out how to synthesize alizarin from coal tar, too, a red to rival the ancient one. It was another triumph, but it also delivered him a cruel lesson about the new, cutthroat world he had helped create. Because a team of German chemists had cracked synthetic alizarin at almost the same moment, and they filed their patent just one single day before Perkin filed his. One day. After all his work, Perkin was beaten to the legal claim by 24 hours. It was a bruising taste of how fast and competitive coal tar chemistry had become. Still, he manufactured alizarin in huge quantities, and the synthetic red swiftly wiped out centuries of madder farming. And stepped back to see what had happened to purple itself, the whole reason the story began. Look at the price of purple across history. For 3,000 years it sat astronomically high, worth more than gold, guarded by law. Then, in the span of Perkin's career, it fell off a cliff. Mauveine collapsed the price of purple from a royal fortune to the cost of any ordinary dye. The most expensive color in human history had become one of the cheapest. That collapse is one of the most dramatic reversals of value in all of history. A substance goes from being the exclusive badge of emperors, something people were executed for wearing, to something you'd find on a cheap bonnet or, today, a child's crayon without a second thought. And it happened because one person, by accident, learned to make the hard thing easy. Knowledge. Once again, turning treasure into the ordinary. But if the story were only about color, it would already be remarkable, and it would still be, in a sense, small. Dyes are lovely, but they're just dyes. What makes Perkin's accident one of the true turning points in human history is what it led to next. Because the coal tar chemistry he unleashed didn't stop at making things pretty. It went on to save lives, by the hundreds of millions. Here's the deep, world-changing consequence. To make all these new dyes, chemists had to become experts at manipulating the carbon-based molecules in coal tar, building them, tweaking them, bonding new pieces on. In chasing color, they accidentally built up an entire science, the science of synthesizing complex organic molecules to order. And that skill, it turned out, was the master key to something far bigger than fashion. It was the key to modern medicine. The dye companies that sprang up, especially the great German firms, with names you still know today, like Bayer and BASF and Hoechst, had grown rich and skilled making synthetic colors. And they had armies of chemists who knew how to build molecules. It was almost inevitable that some of them would start asking, if we can build molecules that color cloth, could we build molecules that heal the body? The dye labs turned, slowly, into drug labs. One of the first fruits was a household name, aspirin. It was developed and marketed at the end of the 1890s by Bayer, a company that had started life and made its money as a dye manufacturer. The same coal tar chemistry, the same molecule-building expertise that produced synthetic colors, now produced one of the most widely used medicines in the world. The painkiller in your cabinet is a direct descendant of Perkin's purple. But the deepest connection between dyes and medicine came through a brilliant German doctor named Paul Ehrlich, and it started with the strangest observation. Ehrlich noticed that the new synthetic dyes didn't stain everything equally. Different dyes would soak into different tissues, different cells, and, crucially, different microbes. A particular dye might stain a bacterium vividly while leaving the surrounding human cells almost untouched. The dyes could tell things apart. That selectivity was a revelation, and it powered two revolutions at once. The first was in seeing the invisible. Bacteria are nearly transparent and fiendishly hard to observe. But stain them with the right synthetic dye, and suddenly they leap into view under the microscope, sharp and colored. Robert Koch used dye staining to identify the bacteria that caused diseases like tuberculosis. Synthetic color became the eyes of the new science of microbiology. The second revolution was even bigger. Ehrlich had a dazzling idea. If a dye could selectively stick to a bacterium and ignore human cells, then what if you attached a poison to that dye? The dye would carry the poison straight to the microbe, killing it while sparing the patient. A chemical that hunts down only the disease. He called this dream the magic bullet, a drug with perfect aim. And it came straight out of dye chemistry. In 1909, Ehrlich and his team made the dream real. After screening hundreds of compounds, they found one, a synthetic arsenic-based molecule developed with all the tools of dye chemistry that could cure syphilis, one of the most feared diseases of the age. They called it Salvarsan. It was the first true chemotherapy, the first time a specifically designed chemical was used to cure an infectious disease. Modern pharmaceutical medicine was born. Follow that thread forward and it becomes almost overwhelming. Ehrlich's dye-inspired approach, screen chemicals, find the one that selectively hits the disease, became the fundamental method of the entire pharmaceutical industry. The antibiotics, the cancer drugs, the antivirals, the whole modern arsenal of medicine that keeps you and everyone you love alive, the intellectual seed of it lies in noticing that Perkin's synthetic dyes stain some things and not others. So trace the causal chain, because it's staggering. An 18-year-old fails to make quinine. He notices his failure dyes silk purple. That purple launches a synthetic dye industry. That industry teaches humanity to build complex molecules and reveals that dyes can target specific cells. That insight creates modern pharmaceuticals and microbiology, which go on to save hundreds of millions of lives. All of it, unspooling from one pot of black sludge in an attic. And it wasn't only medicine. The coal tar chemistry Perkin pioneered became the foundation of the entire modern chemical industry. From it flowed synthetic perfumes, flavorings, explosives, plastics, photographic chemicals, and eventually the whole vast petrochemical world. Learning to build molecules for color was humanity's training course in building molecules for everything. The synthetic age, the made world we now live in, has one of its taproots in that flask of mauve. There's a bittersweet twist in the industrial story, though. Britain. Perkins. Britain had invented the synthetic dye industry, but it let the lead slip away. Germany, with its superb chemical education and aggressive investment, seized the field. Watch the shift. Within a generation, the industry born in a London attic was overwhelmingly German. By 1913, Germany produced around 85% of the world's synthetic dyes. Britain, the birthplace, made a small fraction. The lasting lesson in how invention and industry can come apart. Being first to discover something doesn't guarantee you'll be the one to profit from it. Britain had the spark, a teenager's genius, but Germany had the system, the trained chemists, the research culture, the willingness to invest. The country that builds on a discovery can outrun the country that merely makes it. Hofmann, tellingly, went back to Germany and helped it soar. And there's a darker coda, too, that honesty demands. Those mighty German chemical firms, grown from dyes, eventually merged into a giant conglomerate, and in the 20th century, that same coal tar chemistry turned to terrible ends, produced poison gases and worse. The knowledge that gave us color and medicine also gave us new ways to kill. Chemistry, like all powerful knowledge, was never only good or only evil. It was simply power, and power can be turned either way. But return to Perkin himself, because his own arc has a lovely final act. By the 1870s, he was still a young man, but immensely wealthy from mauve and alizarin and his other dyes. He had built an industry, changed fashion, and unknowingly seeded modern medicine. And in 1874, at just 36 years old, William Perkin did something remarkable. He sold his factory, cashed out of the business entirely, and walked away from industry for good. Why? Because Perkin had never really wanted to be an industrialist. He'd become one to seize an opportunity, and he'd done it brilliantly. But his true love had always been pure chemistry, the science itself, for its own sake. So, rich and free at 36, he retired to his own private laboratory to spend the rest of his life doing exactly what he loved, fundamental research, chasing knowledge with no thought of profit. He'd earned the freedom to be curious, and he made real contributions in that second life, including important discoveries in how molecules relate to magnetism and light, work that mattered to chemists for generations. The boy who'd gotten lucky with a purple accident proved over a long career that he was a genuinely gifted scientist, not merely a fortunate one. Luck had opened the door, but it was Perkin's mind, all along, that had walked through it. Let's lay out the whole family tree that grew from his flask, because it's the heart of the story. From one pod of coal tar sludge branch, the synthetic dyes, the rainbow that recolored the world. From the dyes branch, the medicines, aspirin, Salvarsan, the whole pharmaceutical age. And from the dyes branch, the stains that let us finally see bacteria, founding modern microbiology. One accident, 3 world-changing branches, countless lives touched. It's worth sitting with how improbable every link in that chain was. Perkin was trying to make a malaria drug and failed. He happened to use a starting material that gave purple. He happened to clean the flask instead of just dumping it. He happened to know purple was valuable. He happened to have the nerve to defy his mentor. Change any one of those, and there's no mauve, no dye industry, no magic bullet. At least not then, not that way. And yet, and this is the deeper truth, maybe it wasn't purely fragile. Because the coal tar was there, the chemistry was ripening, chemists across Europe were poking at these same materials. If Perkin hadn't stumbled onto synthetic dyes in 1856, someone likely would have within a decade or two. The discovery, in some sense, was ready to be made. But it took a curious, bold, observant 18-year-old to actually reach out and grab it first. That tension runs through so much of science. Discoveries have their moment, a time when the pieces are in place, and the breakthrough is almost inevitable. But someone still has to be the one to see it, to recognize the flash of purple in the failure and understand what it means. The world provides the opportunity. It takes a prepared, curious mind to notice it. Perkin's genius wasn't the luck. It was the noticing. There's a phrase for this in science: chance favors the prepared mind. Perkin is one of its purest illustrations. 100 people might have made that same black sludge and washed it down the drain, annoyed at another failed experiment. Perkin made it, and saw a color, and saw a fortune, and saw, though he couldn't know it, the doorway to modern medicine. Same accident. Different mind. That difference is the whole story. So the next time an experiment fails, in a lab, in a kitchen, in your own life, remember Perkin's attic. Remember that the most important discoveries often arrive disguised as mistakes. The black sludge that ruins your plan might, if you look at it closely enough, be glowing faintly with a purple you never expected. The failure isn't always the end of the story. Sometimes it's the beginning of a much bigger one. William Perkin was knighted late in his life, honored at last as the founder of an industry that had reshaped the world. He lived to see the 50th anniversary of his purple accident celebrated on both sides of the Atlantic. And he died in 1907, a rich, respected, and happy man, the teenager who failed to cure malaria and, in failing, accidentally colored the modern world and seeded the medicine that fills it. Let's gather the threads of this astonishing tale, because it's braided from several lessons, and each one is worth carrying with you. It begins, as we said, with the color purple, and what purple can teach us about the strange, shifting nature of value itself. The first lesson is about value, and how fragile it really is. For 3,000 years, purple was the ultimate luxury, not because there was anything magical about the color, but because it was hard to make. Its value was really a measure of difficulty, and the moment one clever teenager made it easy, all that value evaporated. The color of emperors became the color of crayons overnight, in the sweep of history. That's a genuinely profound idea, and it reaches far beyond dye. So much of what we call precious is precious only because we haven't yet learned the trick of making it. Scarcity is often just a problem waiting to be solved, and when someone solves it, a treasure can become ordinary in a heartbeat. It makes you wonder what we consider precious today that our grandchildren will buy for pennies without a thought. The second lesson is about accidents, and about the difference between having one and seeing one. Perkin's discovery was pure luck. But the world is full of lucky accidents that lead nowhere because no one notices, no one wonders, no one follows the thread. What made Perkin extraordinary was not that purple appeared in his flask. It's that he stopped, looked, and asked the right question instead of reaching for a rag. This is the essence of serendipity in science, and it's not really about luck at all. It's about preparation and attention. Fleming and penicillin, Perkin and mauve, so many others. In each case, chance offered something unexpected, and a curious, knowledgeable mind was ready to catch it. The universe scatters clues constantly. The question is always whether anyone is awake enough to see them. The third lesson is the most beautiful, and it's about how everything connects. When Perkin dipped that silk in purple, he could not possibly have imagined that he was setting in motion the discovery of chemotherapy, the founding of microbiology, the birth of the pharmaceutical industry. He was just trying to make a nice color. But knowledge is a web, and pulling one thread tugs 1,000 others. A dye became a stain, became a cure, became a whole age of medicine. You truly never know where a discovery will lead. The most abstract, useless-seeming curiosity, why does this sludge turn purple, can wind its way, across decades, into something that saves your child's life. This is the great argument for curiosity itself, for pure research, for following interesting questions even when nobody can say what they're for. The purple in the flask had no obvious purpose. It led to the modern world. And there's a fourth lesson, tucked in the quietest part of the story. Remember that Perkin was 18, a teenager, an assistant, a nobody, told by the greatest chemist he knew that his idea was foolish. And he was right, and the great man was wrong. Age and authority and reputation are no guarantee of vision. Sometimes it's the young, the fresh, the outsider, the one who doesn't know what's supposed to be impossible, who sees the new thing clearly. There's such encouragement in that. You don't need to be established or credentialed or old or certain to change the world. Perkin had a home laboratory, a school holiday, a failed experiment, and the courage to trust his own eyes over his mentor's advice. Great things can come from humble places and unlikely people. The next Perkin might be a curious teenager right now, staring at something everyone else calls a mistake. It's worth remembering, too, what Perkin was actually trying to do, cure malaria, and that he failed at it completely. His great gift to humanity was not the thing he set out to make. It came sideways, unbidden, out of the wreckage of his real goal. So often, that's how it works. We aim at one target, miss, and hit something we never even knew was there. The value of the attempt is not always the thing you are aiming for. And it's a reminder to be generous with our failures, our own and other people's. A failed experiment is not wasted. It's information, it's exploration, and every so often, hiding in the disappointment, there's a flash of purple that changes everything. The people who make the biggest discoveries are rarely the ones who never fail. They're the ones who fail, and then look closely at the failure instead of turning away. So consider the ripples of that one Easter holiday in 1856. The clothes people wore, the colors of the modern world, the founding of a global chemical industry, the birth of microbiology and the ability to see our microscopic enemies, the dawn of pharmaceutical medicine and the magic bullet. Hundreds of millions of lives saved or improved down the long chain of consequence. All of it flowing from an 18-year-old's beautiful mistake. That's really the invitation of this whole series, to look at the ordinary world and see the astonishing history packed inside it. To look at a purple crayon, a bottle of aspirin, a stained microscope slide, a brightly colored shirt, and see, hiding within each one, a teenager in an attic, a pot of black sludge, and a flash of the color of kings blooming out of a failure. Because once you know the story, you can't unsee it. The colors around you stop being ordinary. That purple is an emperor's color, made cheap by a boy's accident. That painkiller is a descendant of coal tar. That vivid shirt exists because someone learned to build molecules while chasing beauty. The made world is full of these hidden epics, and every one of them makes reality richer, stranger, more astonishing. And it leaves us with a genuinely hopeful thought. If a failed experiment on a school holiday could recolor the world and seed modern medicine, then discovery is not the private property of geniuses and grand institutions. It's lying around everywhere, in every unexpected result, waiting for a curious mind. The extraordinary is closer than it looks, sometimes as close as the bottom of a flask you are about to wash out. So let's give William Perkin his due. Not a saint, not a lone untouchable genius, A clever, bold, hard-working teenager who got lucky and, crucially, was ready for his luck. Who defied his mentor, gambled his family's savings, and built something world-changing out of a mistake. Who then, having made his fortune, walked away from it to spend his life simply being curious. There are worse models for a life than that. We began with the color of emperors, a purple so precious it was walled off from ordinary humanity for 3,000 years, worth more than its weight in gold, guarded by law. And we end in a world where that same color is everywhere and costs nothing, where the chemistry that freed it fills our medicine cabinets and our microscopes and our entire made world. That vast distance was crossed by one accident, in one attic, over one Easter break. That's how much one curious mind, catching one lucky accident, can change everything. Perkin didn't set out to remake the world. He set out to cure a disease, and failed, and paid attention to the failure. And in that attention, in that one decision to look closely at the sludge instead of pouring it away, the modern age quietly began. So the next time you see the color purple, on a sign, a flower, a piece of plastic, a child's drawing, let it mean something to you. Let it remind you of Tyrian snails and Roman emperors, of a teenager's failed medicine, of black coal tar sludge and a flash of unexpected violet, of the birth of chemistry and medicine and the colorful made world you live in. All of that, in a color you'd otherwise never notice. From more precious than gold to the crayon in a child's hand. That's the story of purple, and of William Perkin, and of the accident that made the modern world. A color, a mistake, a moment of noticing, and a chain of consequence that runs from an attic in 1856 all the way to the medicine that may one day save your life. Stay curious about the ordinary things, the colors, the objects, the everyday stuff you never think twice about. Every one of them was once a mystery, a struggle, an accident, a triumph. And knowing their stories turns a world of dull, taken-for-granted things into a world of quiet, secret marvels. If this story stuck with you, do two quick things. Hit subscribe. Neat Science brings another forgotten story back to life, and there's a whole playlist of them waiting for you right now. And tell me in the comments, which part of this surprised you the most? I read every single one. So keep exploring. Your next story is just one click away. I'll see you there.